Look around you. Right now, there is a silent engine running almost everything in your life. It's in the device playing this video. It's in the car parked outside, and it's even in the bank card in your wallet. Most people think of technology as wires, screens, and electricity, but the real magic isn't the electricity itself. It's the gatekeeper that tells that electricity where to go. For thousands of years, we only had materials that either let electricity flow freely, like copper wire, or blocked it completely, like glass. But what if there was a third option? A material that could choose, a rock that could think? We call them semiconductors, and without them, we'd still be living in the age of steam engines. Today on Simple Things Surprising Histories, we're going to crack open the micro world to discover what a semiconductor actually is, the happy accident that led to its creation, and how we turn plain beach sand into the smartest object on Earth. To understand how a semiconductor works, we have to look at how electricity moves. Imagine electricity like water flowing through a pipe. In metals, like copper, the pipe is wide open. Electricity flows uncontrollably. These are conductors. In materials like rubber or glass, the pipe is sealed shut. Nothing gets through. These are insulators. A semiconductor is the Goldilocks material. It's right in the middle. By itself, pure silicon is actually a boring insulator. It blocks electricity. But here is where the science gets fascinating. If we inject a tiny amount of impurities, like phosphorus or boron, into the silicon crystal structure, we change the game. This process is called doping. Think of doping like adding a drop of food coloring to clear water. It fundamentally changes the properties. N-type doping adds extra electrons, while P-type doping creates electron holes, empty spaces for electrons to jump into. When you sandwich these two types together, you create a gate. You can tell the current to stop or go just by applying a tiny voltage. This is a transistor, a digital switch. It's a simple on-off switch, but when you pack billions of them together, that simple on-off becomes the ones and zeros of computer code. So this ability to switch electricity on and off is the basis of all modern life. But who figured it out? The history goes back farther than you think. In 1833, the famous scientist Michael Faraday noticed something weird. Silver sulfide conducted electricity better when it was hot, unlike metals, which usually conduct worse when hot. He didn't know it yet, but he had just documented the first semiconductor effect. However, the real leap in making them came from a clumsy mistake. In 1916, a Polish chemist named Jan Czochralski was working in his lab. He was busy writing notes, and without looking, he reached for his inkwell to dip his pen. But he missed. Instead, he dipped his pen into a crucible of molten tin. When he pulled the pen out, he didn't get ink, he pulled out a thin, perfect thread of metal crystal. He had accidentally discovered how to grow single crystals, a method now called the Czochralski process. Today, this exact method, pulling a seed crystal slowly out of molten silicon, is still how we grow the massive silicon ingots used for every chip in your phone. A moment of clumsiness changed the world forever. But how do we get from a single crystal to the chip in your phone? The process is arguably the most complex manufacturing feat humans have ever achieved. It starts with sand, specifically silica sand, which is mostly silicon dioxide. We heat this sand to extreme temperatures to remove the oxygen, leaving behind 99.99999% pure silicon. Using Jan Czochralski's method, we grow a giant sausage-shaped crystal called an ingot. This is then sliced into discs as thin as a sheet of paper called wafers. Next comes photolithography. This is essentially painting with light. Engineers use ultraviolet light to project microscopic blueprints of circuits onto the wafer. We are talking about details thousands of times smaller than a human hair. They etch away the unneeded parts and bombard the silicon with ions to do that doping process we talked about earlier. The result is a single chip the size of a nail that contains billions of transistors, all working in perfect harmony. It is a skyscraper of engineering, built on a foundation of sand. So, this ability to switch electricity on and off is the basis of all modern life. But today, these chips are everywhere. They're the brains of your microwave, the safety system in your car, and the guidance system of satellites. But if you wanted to find them in bulk, where would you go? Geographically, you'd look to East Asia. Taiwan and South Korea are the global titans of production, hosting massive fabs, fabrication plants that churn out the majority of the world's advanced logic chips. However, there is another place you can find semiconductors in bulk, and it's a problem we need to solve: e-waste. Because semiconductors are in everything, they pile up in our trash. Interestingly, there is now more gold and rare earth minerals in a ton of discarded smartphones than there is in a ton of gold ore from a mine. This has given rise to urban mining, recycling these old chips to harvest the precious materials inside. So the semiconductor life cycle comes full circle, from the sand of the earth to the brain of a computer, and eventually back to the raw elements to be used again. It is strange to think that the smartest tools we possess are essentially just rocks that we taught how to do math, but that is the magic of the semiconductor. If you enjoyed discovering the secret life of the silicon chip, make sure to hit that like button and subscribe to Simple Things Surprising Histories. We have plenty more stories hidden in plain sight waiting for you. See you in the next episode.